Hey everybody, hopefully you're coming right back. Hopefully you didn't miss me for too long, unless you just couldn't take the sound of my voice anymore, and so you took a break and you went to get some fruit snacks, and then you came back. Okay, I have to be honest and tell you there's parts of this classwork I hate, so I'm gonna do my own thing a little bit. If you're following along in the ebook, which you should do, I will try my best to tell you where I'm at. Okay, so I hate this first problem already. But we need the practice. So what I want to focus on here is the original series, which is all of the rectangles on the bottom of this graph. There are 16 bars. The first bar is 2 high. The last bar is 11 high. Please don't worry about flipping it on top. They're just trying to make it into a rectangle so it's easier to calculate, but it really isn't easier. So anyway, okay, so we're going to skip A. What is the sum of Antonio's series? How do you know? Okay, so we can do that. So 10-21b sum equals n over 2 t of 1 plus t of n. Okay, so the number of bars in this is 16. Again, we're looking at all the bars along the x-axis, not just the shaded ones, all of them along the bottom there. 16 over 2. The height of the first bar is 2. Oh no. Okay, we're gonna fix this. Plus the height of the last bar is 11. I don't know why there's extra parentheses. Please just, I love you all, sorry. Okay, so that sum is 104. Okay, now C says, which terms of the series form the first column? What is the height of this column? We're skipping that. Okay, but D, I want to do, write out Antonio's series and compute the sum. Okay, we already know the sum, but what we need to do is practice finding the other pieces. What I want you to notice in this problem is it's like almost impossible to tell what the growth is. I actually, if it makes you feel any better, had to check the teacher's manual to tell what the growth is. I do know that there's 16 numbers. I do know that there are, the first number is 2, and then I've got a lot of numbers, and then my last number is 11. However, I don't know the growth. Okay, so this is going back to that one that I knew probably threw you for a loop, number 6. So I wanted to do that one again, which is why I am focusing on this. Okay, so what I'm looking for is the growth. Notice I don't have the 0th term. I can't find it, so I need to write my equation in terms of the first term, which I taught you to do in the first video. So t of n equals growth, which we're going to just call m for slope, times n minus 1 plus the first term, which is t of 1. Okay, and remember this is equivalent to growth n plus 0th term, which would be t0, but we don't have that, so we're going to go with t1. Okay, t of n in this case is the last term, which is 11. Growth is what we're looking for. The number of terms is 16, and the first term is 2. Okay, you can already tell from the numbers that this is going to be gross. Minus 2, 9 equals m times 15. Divide by 15. What's 9 divided by 15? 0.6. The growth is 0.6. So looking back at that picture now, you can kind of see that the growth is 0.6, but I never would have guessed it from that. So we would have 2, 2.6, 3.2, etc. up to 11. Okay, Number 22, it says create a series that has an odd number of terms. We're not going to do that. So we're going to call this notes, guys. So if you are putting notes in a different place in your notebook, now would be the time to flip there. Arithmetic sequences in series. Okay. Here is the first thing you need to know. Arithmetic sequences have a common difference. And we call that the growth, or M for slope. And this is repeated addition. I want to spoiler alert you a little bit that there will be repeated multiplication ones coming up. Those will be geometric. Hopefully that word sounds familiar from Math 1. Arithmetic sequences have a couple of formulas. T of n equals growth n plus 0th term, or the one that we've been using lately, T of n equals growth n minus 1 plus the first term. Okay, so this one is nice because if you're graphing or something, you have the y-intercept here. This one's nice because you don't need the 0th term to be able to write it. So either one is fine. Okay, and series have a formula which is the sum equals n over 2 t of 1 plus t of n. Okay. All right, so we're going to do an example, which is 11 plus 18 plus 25 plus ... plus 74. And I want to find the equation and the sum. Okay, now this is a series. We're going to find the equation for the sequence, and remember there's two of them, so we're going to write both. So in terms of the 0th term, that's easy to find because you guys can tell these are going up by 7s, I hope. So the 0th term would be down 7, which is 4. Okay, so if I have the regular one that we're used to from Math 1, we have T of n equals growth n plus 0th term. So remember that little 4 would be out here. Or, which is our new one, which we can use when we don't know the growth, T of n equals 7 n minus 1 plus 11. The advantage of this is I don't need to know the 0th term. I can just write it the way it's given. Okay, now I need to know the sum. Notice for the sum formula, it requires n over 2 t of 1 plus t of n. I know t of 1 is 11 and t of n is 74, but I don't know how many numbers this is. Can I figure this out by messing around on the calculator? Absolutely. Am I going to do that? No. What I'm going to do is use this lovely explicit equation I have here to figure out how many terms out that 74 is. So 74 equals 7n plus 4. Oh, I like the looks of this. 70 equals 7n. 10 equals n. Okay, so what that means is 74 is 10 numbers out. Okay, sum equals 10 over 2, first number plus last number. Okay, which equals 425. Okay. Now, for 23, I'm back to classwork here. It says, will Antonio's method work for any arithmetic series? Why or why not? Use an example to explain your conclusion. Don't really care to do that. What I am going to do is take some problems from 24. I like 24. It's got different examples with different things. So we are going to take 23 and actually do 24b. If you noticed, by the way, our notes was actually problem 24a. Okay. So we are going to do problem B from 24 as our 23 because it told us to come up with an example. So look, I did. It says 14 terms with t of 1 equals 8 and t of 14 equals 151. Okay, so what does this look like? T of 1 is 8, and then it's going out, and then the last number is 151, and we know that 151 is the 14th number out. This is great. We have everything we need to find the sum. We don't even need to do any fancy algebra. So there's 14 numbers over 2. The first number is 8. The last number is 151. And I have 1,113 for that sum. Hey, I like that one. Okay. 1024, can I fit it? Is going to be problem 24C. I knew you guessed it. Okay, and this one says t of n equals 6n minus 2 for first 25 terms. Okay, so what do we know? We know the growth. We know n, there's 25 numbers, so we're going to have sum equals 25 over 2, something plus something. Okay, how can I get these? How can I get the first number and the last number? Well, I hope you're screaming at your screen. T of 1 is going to be what I get when I plug 1 in. 6 times 1 minus 2 is 4. Okay, what should I plug in for the last number? Notice here, they even gave you a hint. T of 1, T of 14. So I should do T of 25. And that is 148. And when you calculate this sum, you get 1,900. Alright everybody, that's it for today. I hope you guys are having a great day. I will post more soon.